So what does it mean? It means when we apply the height of the outrigger system installation type, we need to know that this height, first of all, should be right applied and right calculated. Before was applied, the height of calculation should be done the right analysis and the right calculation of all building. It's a really important task, because if this system or trigger system will be not right, work right, will be not show needable results, it will not help to building to withstand the loads, and it will mean that this system just a simple construction, so it are not increase the bearing capacity. This system is not strengthened at all the building constructions, and so it will mean that we made all job, all work without mm, without any help to the building. So it's just a simple construction. It will be not right. So if we accept it, it should increased, maybe not doubly increased, but it should really help to the building more, be more durable, and be more resistable to the lateral loads like wind load and like the seismic load, which are also one of the type of lateral loads. So 3D image, here is example of nodes or joists, how to can be connected the vertical diaphragm of wall with the belt trusses, which are located from two parts of the building, from longitudinal direction and from the cross-sectional direction. So outrigger systems connected with the diaphragm of wall. Here is a connection. I told you previously that this connection is a rigid connection. The most part of the tallest building in the world are included the outrigger system in their construction. So the outrigger systems help to the tall buildings withstand the loads, I told you. And here you see the dark lines, which are means that there was installed the outrigger system. So the more height of the building, like you see here, the more levels of the outrigger system. So tallest buildings include 4 outrigger, maybe truss belt system. So some the building with some less height in comparison with this included 3 main outrigger systems. When we told about high-rise building, about main story building, so it is important to understand the bearing constructional elements of the building. So we call it like structural system. So this structural system are consist of several important and differently constructional elements. First of all, it is the core wall, or just the core. So inside tall building, most of all in its central part, which consist like the most effectively location in the building. It's a central part of the building to install the core. So the core is the main constructional bearing element in the building. It accepts all loads and transmitted from the top part to the bottom part. And it just by itself, the core cannot accept all loads from the building, because if it will take more than half or maybe all square of the building, it will increase the scale of diaphragm wall location, will increase the own weight of the construction and so on. So it's not economical efficiency to use just only core walls for tall buildings. It used only insufficiently enough volume, dimensions, size, and so on. So just only in central part. And it surrounded by using the materials with the less weight, like you see on this picture. So with plus mega columns and belt trusses. So here we see our trigger systems. So not on each levels. So on the special height. So I told you the tall buildings can be divided in 3 or 4 parts, and each part is a separately increased bearing increased system, which included the outrigger system. So this outrigger truss belts will surround this core and will transmit like on the columns which are installed in the 4 parts. So mega columns, actually there are intermediate columns which are also accept and transmit the loads, but this mega columns means that the section of these columns is more and the bearing capacity is also more. So they are located in the 4 parts in the 4 edges of this building. And through these outriggers, through these mega columns, all external loads, all horizontal torsional loads are accepted by this lightweight, in comparison with this bearing system, lightweight materials, but not with the less bearing capacity. It accepted all actions or all loads and transmitted to this core. And in general, it will be not enough just use core and the mega columns. Like you see on the picture, we need to use secondary frame. Secondary frame, it is additional columns and beams, horizontal walls, horizontal slabs, vertical walls in some time, and all of them are accepted according to the analysis, calculation, and in all of them is one of the effective constructional system which shows the good results with the less deflections, with the less shrinkage and other negative effects of the building, which are found when on the construction, on the tall construction are act the all impacts and loads. So this constructional variant of the system is absolutely that it will reduce them and will protect building from the movement, from the settlements at itself, because decreasing the deflections and plasticity of the building is also positive to reducing the overall settlement differential and the general settlement of the building, because tall buildings have the massive weight, then requires huge foundations, and of course it all requires a really strong basement, strong layers, earth layers, so ground layers, and so on. And the last one, it's a concrete outrigger. So previously I told you about belt truss, which are made from the steel, but the steel actually can be used in the combination with the concrete. So concrete is also one of the decisions to use the outrigger system, because concrete itself uh, and separately, if it will work in combination with the steel, it can show the also higher results in reducing the um, impact of the loads and increasing its stability during the uh, load action to the building. So here is an example of using the outrigger system from the house connected to the column, mega column from the each of the edges to and how it transmits the loads accepted by external part of the building to the central part of the building to the core walls. So here is we see the diagonal connection between main columns to the main core walls, and it's surrounded by the additional frame system, which are also very play not the least role. It's also important. So now we are short of time actually, and I will connect. So we actually will connect our lecture and we'll continue it. After this time will be finished, we'll start next conference. So just let's finish by this slide. Okay.
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 Okay. Thank you very much.